Welcome everybody to tonight's EndoA&P webinar. We are joined by Dr. Fiona McCullough to discuss insulin resistance and fertility. Dr. McCullough is a naturopathic doctor and founder of White Lotus Integrative Medicine in Toronto, Canada, which is an urban wellness clinic which serves thousands of women with hormonal related conditions, and that has been open since 2001. She is the author of 8 Steps to Reverse Your PCOS. And that's kind of, one of her areas of specialty. I think many of you who have been EndoA&P members for a while have probably heard her lecture on that. She is also the medical advisor to and developed a nutrition methodology for the open source health PCOS project, which analyzes molecular, genetic, and metabolic and hormone markers in women with PCOS. And in addition, she is also one of our EndoA&P board members, and there's a lot of other parts of her bio that I could go over in her background, but we want to jump into the juicy stuff. So with that being said, I will pass the floor over to Dr. McCullough, and she will take it from here.
Thank you, Corey, and thanks everyone who's attending. I'm also just super excited that this will be recorded, so I hope that this will be useful for everyone out there who's watching later. This is a lecture on insulin resistance and fertility. So I will be covering PCOS, but I'll also be covering, all of the elements that relate to insulin resistance in general during this lecture. And the outline of what we'll be covering today is we're going to start off with insulin resistance and what is that, what are the definitions and what are the updates that we know about it now. What are the underlying causes of insulin resistance? Because that's always important for us to know as naturopathic doctors. We want to review the impacts of insulin resistance on fertility, of course, so for both males and females, and we'll be covering the different elements that insulin resistance affects. And we'll be reviewing a physical assessment and lab testing for insulin resistance because it can be easily missed in practice, particularly if you don't look deeper. It's often missed actually. Nutrition for insulin resistance, so different dietary approaches that we can use to regulate blood sugar and increase insulin sensitivity, and supplements and botanical medicine approaches to the integrative treatment of insulin resistance. And then if we have any time left, we'll do some question and answer at the end. All right, so I just wanted to start off with an overview of the basic things that insulin does. And it does much more than this, as we'll learn, but the basics of what we often think about when it comes to insulin is that it stores energy. So whenever we eat a meal and our blood sugar raises, our insulin raises in response to that. And it takes the sugar from the bloodstream and directs it into the cell so that it can be stored. It can be stored as fat long-term, and it can be stored also in the liver as glycogen. And also in the muscles as glycogen as well. So insulin is definitely a storage hormone. It's made to be released after eating. And as a result, it has another function, which is to block fat breakdown, which makes complete sense. We are not made to have lots of food. And so if we've just eaten, we're not going to be breaking down fat. It's just not efficient. So because insulin is a signal of, nutrition, it's also a signal to block fat breakdown. So it's definitely a storage hormone, and it's involved in anabolism primarily. Insulin also does a lot of other things, and pretty much every cell in the body has an insulin receptor in it. And it has a variety of different functions. Most of the functions are generally anabolic in that it's going to increase growth pathways. It's important for storage of energy. It's got crucial roles in reproduction. And it's very much involved in the way the liver metabolizes fuel. It's involved in the way that our DNA synthesizes proteins. So it has a lot of different functions in the body, and we want it to be working properly. We don't want it to be dysregulated because it is such an important and key hormone in the body. So what causes insulin resistance? And, the vast majority of insulin resistance today is caused by overnutrition, meaning that too much food is consumed over a long period of time. When that happens, which is very, very common with the Western diet, it promotes lipid accumulation in the skeletal muscle and liver, and it promotes insulin resistance in those tissues. It also promotes adipocyte insulin resistance and enlargement of adipocytes. When adipocytes get enlarged, they will begin to leak free fatty acids, and they actually die because they have poor circulation. That causes chronic inflammation and cytokine release from the adipose tissue. And accumulation of intrahepatic triglyceride also induces hepatic insulin resistance and increases hepatic glucose production. So all of these different ways that chronic overnutrition, so overconsumption of calories over time, will actually cause insulin resistance. And this is definitely the vast majority of insulin resistance that you'll see is primarily caused by overnutrition. And here's just a look at what happens to our adipose cells. So when our adipose cells are healthy, they have okay circulation compared to other cells in our body. The fat tissue is not that well circulated, but when it's healthy, it has better, okay circulation so that the cells remain alive at least. And that environment allows the adipose cells to function in an optimal way so that they're secreting adipokines like adiponectin and cytokines like IL-10. These are anti-inflammatory, and they send signals throughout the body, that are beneficial for us and work well with our metabolism. When we have overnutrition, our fat cells become stuffed with energy and with lipids. And this actually blocks circulation to the fat tissue, and we actually end up with necrosis inside the fat tissue. This is something called lipotoxicity, and this is a huge part of why overnutrition causes insulin resistance. So these dying fat cells in the middle of the fat tissue just leak out their contents, which are fatty acids. And the immune system has to clean all of this up. And, what is that? That results in inflammation. And the types of cytokines that are released here are generally those Th1 cytokines that are very similar to the types that you'll see in infections. They are the types that we see in chronic low-grade inflammation, and they induce insulin resistance in many different tissues. And we'll also see a reduction of the good adipokines like adiponectin in this as well. So the way that the fat cells function is a huge part of why we actually develop insulin resistance. And some people are more prone to this than others. But over time, if anybody overconsumes in a chronic way and gains significant weight, they will start to develop insulin resistance for the most part. There are ways to be more metabolically healthy, but in general, when there is overnutrition, you will definitely see more insulin resistance and a rise in insulin levels. There is another type of situation which you'll see in some people. It's not as common, but it's something that I do see, which is impaired insulin clearance. And in people that have insulin resistance and people that are obese, they actually, because of being obese, they do have lower insulin clearance in the first place. However, there are some lean individuals who have impaired insulin clearance as well. And this is common. It's a genetic a tendency that's more common in lean Southeast Asians. So if you ever come across a patient in this situation, what I've seen on testing, and I'll show you some of the testing that we do, is that their fasting insulin is really good, but if their insulin is stimulated, they become, you'll see massive releases of insulin, and they take a long, long time to go away. So, or to clear out. So these people can definitely still be insulin resistant. And it's because of the way that this type of genetic, it affects one type of insulin resistance, which isn't as much associated with obesity. But they will still tend to have high insulin levels, particularly if they're stimulated. However, that is much less common. And I would say for the most part, you're going to see that it's overnutrition. And then I'll also be covering PCOS as well. So PCOS is a little bit more complex in that it has another factor involved, which is androgen excess. And androgen excess actually can cause insulin resistance through a few different mechanisms. So they've been able to show this in a variety of different studies, but if you expose adipocytes to androgens, they actually will begin to expand and decrease their adiponectin content, increase the release of free fatty acids and cytokines. And for some reason, my text did not show here, but with the liver, you're going to see increased hepatic glucose output and increased hepatic insulin resistance. And so these are direct results of androgen exposure. And this can be induced prenatally, but it can also be induced in adults who are exposed to androgens. So it's a definite factor whenever you're looking at the causes of insulin resistance in someone who has PCOS. The androgen excess itself can be a cause. And then another cause is cortisol and glucocorticoids if patients are on medication. So with glucocorticoid exposure, different tissues respond in different ways, but in all of these situations, it does translate into insulin resistance. So when you're exposing adipose tissue to cortisol, for example, you'll see a decrease in adiponectin and an increase in free fatty acid composition. In muscles, you'll see a decrease in insulin signaling. In liver, you'll see increased steatosis, gluconeogenesis, and hyperglycemia. And of course, then you'll see dysregulation of the HPA axis by hyper and hypoglycemia. So the HPA axis is very much dysregulated by changes in blood sugar, in particular hypoglycemia, and then the feedback loops can be affected. So this can become a vicious cycle with cortisol and insulin resistance. So that always has to be looked at as a potential contributor too, to patients who, are stuck. And so it's always good to look at stress levels and ways to promote healthy cortisol secretion. So now that we've covered the basics of insulin resistance, I just wanted to talk about fertility, because insulin resistance has a very unique role when we're thinking about fertility. So if we're thinking about longevity and then we're thinking about fertility, they're kind of different in the way that we're our bodies are functioning. So fertility, we want to reach a happy medium. We don't want to be in nutrient deprivation mode, and we don't want to be in nutrient excess mode. Whereas longevity is a little bit different, more towards restriction, and it can actually promote longevity. So there has to be a nice balance when it comes to fertility. And the other consideration with fertility is that everything that you're doing to improve fertility when it comes to insulin resistance has profound effects on the baby's health and even many generations ahead. So it's really powerful what you can do when it comes to this. So one of the ways that insulin resistance affects fertility is with follicle health and egg quality. The next is through affecting semen quality and sperm health. And the next is through causing different hormonal dysregulations. And finally, implantation and increased risks of miscarriage. So we'll be going through each of these individually and learning about the different ways that insulin resistance can affect these issues. First, I just wanted to talk a little bit about folliculogenesis, and I'm just using the ovary as an example here. Sperm actually go through a similar type of process. It's shorter, but the follicles begin development for more than 300 days before we ovulate. So they will come up to what we call the primordial state, and then they'll come up to the antral. The primordial state is very tiny, and the follicle rests in that state for a very long time, and it will develop up to the antral state, which is where it is at the beginning of a cycle during the period, and then it will go through rapid development through that cycle, through the follicular phase. up until ovulation. So this process is very interesting. It takes a long time, and the follicles are susceptible to the environment during this entire time because they are developing. But particularly when they start to go through more of the rapid development, that's where they do become much more susceptible to the environment. So if you're looking at 3 months before, you're going to really be seeing a lot more influence, and particularly on the cycle too, you're going to be influencing the development of the follicle quite a bit. And I just wanted to include a basic diagram of the oocyte here and the follicle. So just as a review, if we're looking at the picture on the right, this is a follicle, an ovarian follicle. And the follicle actually is comprised of the oocyte, which is in the middle, and that's the egg. And so that's, the part that, creates the baby. And outside of that is its life support system, which is the follicle. And the follicle is comprised of many different small cells that support the oocyte, and there's fluid around as well, and circulation. So directly outside of the oocyte, the cells that surround the inner area are called the zona granulosa and the granulosa cells. These cells actually primarily are responsible for estrogen production, and their fluid is actually what bathes the oocyte in nutrition. And so those granulosa cells in the oocyte actually supply nutrients to the oocyte so that it can grow and develop normally. Outside of that is the theca, and the theca is the outer shell. Those cells make primarily testosterone. They also make progesterone in the luteal phase, and there's circulation in that area. So that's where a lot of blood flow comes in. So those as you get to day 3 of the cycle, these cells actually go through rapid changes with the hormone production, and the nutrition is provided to the oocyte so that it can go through development. So the oocytes use different types of fuels. They use pyruvate and glucose. The granulosa cells use amino acids, so glutamine, glycine, cysteine, and others. The lipids are actually stored inside the oocytes, close to their mitochondria. So the oocytes have a lot of mitochondria because they actually have to produce a lot of energy. They have to have a lot of power, and they accumulate a lot of lipids close to their mitochondria. And as they get close to maturation, all those stores decrease and they're used up in beta oxidation to fuel the oocyte. So the follicular fluid actually increases a lot during the development of the oocyte. And what they found is that fluid really reflects the metabolic environment of the entire body. So whatever is happening in the body, the oocyte is being bathed in that fluid, whether that be lack of nutrition, for example, or inflammation or hormonal changes or insulin resistance, or elevated insulin levels causing insulin resistance. So all of these elements here are, really important when we're thinking about this. Okay. So if you think about it, in the body, when you have insulin resistance, what's going to happen here is that you will have a lot of different changes, and we talked a little bit about that. But we're going to be seeing things like increased free fatty acids, increased inflammatory cytokines floating in the blood, increased insulin levels. And so when we're thinking about the follicle and we're thinking about what's happening with the oocyte, it actually has to use all its mitochondria, and those mitochondria actually undergo very specific changes during maturation, the mitochondria themselves. And excessive reactive oxygen species, as we know, like any other cell, can damage mitochondrial function in oocytes. And because oocytes are so dependent on this, it's much more of a problem when it comes to egg quality. So the follicular fluid that's bathing the oocyte, as I mentioned, does completely reflect these metabolic disorders such as insulin resistance. It contains more glucose, it contains more free fatty acids that can cause damage to the endoplasmic reticulum and the mitochondria. And what they found is that this can disrupt meiosis, which is the process of development, and that can cause major problems with egg and embryo quality. And then even further to think about that, the oocyte transfers its mitochondria to the embryo. And so those mitochondria that are impacted by this environment will now be part of the embryo's mitochondrial environment also. So it's pretty major if you think about what you can do by changing this. So going further into that, so if we think about the oocyte being influenced, by all of this insulin resistance, and that would definitely be true in a condition like PCOS if there were insulin resistance. So just to review PCOS, there are 3 criteria. You just need 2 of the 3 to have a diagnosis. The first, and what I believe the most important one that has to be there, is androgen excess. And it's hard in certain ways to go off of biochemical androgen excess, but clinical androgen excess is a criteria that's acceptable. So looking for hirsutism or significant acne or androgenetic alopecia, even if they have normal androgens, that's definitely going to be considered androgen excess. Oligo or anovulation, generally 35-day cycles or longer, and then polycystic ovaries on ultrasound, which is not a very accurate criteria, but it is one. So 2 of those 3, and the majority of women with PCOS do experience insulin resistance. And the reason for that is that the androgens actually induce the insulin resistance. So, this is definitely a factor in PCOS. And if we're thinking about it to go even further, because PCOS, it's not just the androgen excess, the insulin resistance that affects the fertility, it's actually also the androgen excess. And then, PCOS as well is very much a developmental and epigenetic type of condition, the more that we're learning about this. So when we're talking about fertility, we have to really talk about developmental endocrine disruption. How can we prevent PCOS in future generations? So there is a lot of evidence now to show that, developmental endocrine disruption is definitely a factor in PCOS. It can be induced in animal models by specific endocrine disruptors in the prenatal environment and persist for generations. So this is a major thing. And of course, estrogens, plastics, so endocrine disruption in the prenatal environment, in addition to the mother's androgen excess, the mother's insulin resistance. So all of these can actually cause a PCOS type condition to manifest. And so what happens is during that key developmental time when the ovary is developing and then the brain is becoming exposed to, for example, testosterone, excessive testosterone, those changes will remain dormant until the onset of adrenarche and puberty. And then when hormones begin to be produced, then the PCOS is unmasked. So this is what a lot of the new information is showing us that, really contributes to the cause of PCOS. So it's a combination of endocrine disruption, androgen excess in the prenatal environment, which we can definitely help influence, and then, endocrine disruption. So yeah, so this is really powerful in that, we're going to be able to, by working on this, prevent problems for offspring and even numerous generations ahead. So this is just an example of how this could happen. And so if there's a prenatal endocrine disruption, for example, bisphenol A, or it could be the mother has androgen excess, the brain, the ovary, the adrenal development is influenced by that. And then hormonal production at puberty unveils those hormonal imbalances that originated during development. And another final thing that happens that makes it really tough to get out of this cycle is that with androgen excess at puberty, which all girls have, but women with PCOS have much more than that. There's also an increase in cortisol at that time, so that weight can be gained for reproduction. But when you combine that with androgen excess, there's a lot of increased fat storage that happens. And there's also a lot more androgenization of the brain causes more difficulties controlling impulses to eat, for example, to eat carbs or sugars, and a lot of teenage girls at this age end up just eating quite a lot and developing different kinds of eating disorders. And so it just becomes very easy to gain weight. And it's really quite a vicious cycle because hyperinsulinemia triggers androgen excess. So it really all just becomes a vicious cycle that starts up at puberty. So if we're looking again, at what testosterone does to in females, this is excessive testosterone, not normal levels, so excessive testosterone. In the brain, it reduces ovulation. It actually has impacts on leptin that increase visceral fat, adipocyte size, lipids, and fatty liver. It increases fatty liver and glucose in the liver. As discussed, it has negative effects on the adipocytes. And then in the ovary, it actually degenerates the granulosa cells, which are the cells that provide the nourishment to the oocyte and the cells that provide estrogen. And so there's a degeneration of those cells. So that's going to affect the oocyte quite a bit if you think about that. And then it causes theca cell hyperplasia, and theca cell against the outside that makes testosterone. So it's a vicious cycle where it causes more testosterone production, and that slows the development of the oocyte as well. So, the excess testosterone is a major factor when you're looking at insulin resistance in PCOS, because in many ways it's actually a cause of the insulin resistance. Although, when we get to the treatment section, I'll show you that it's generally easier to lower insulin resistance than androgen excess. So it's always important to do that very intently. When it comes to PCOS and fertility, I just wanted to include a couple of pearls that I use, because sometimes it can be really hard to tell if somebody has PCOS, especially if they're a little bit older. They definitely may not have some of the androgen excess signs. And when we're looking at fertility, anti-Müllerian hormone can be a functional marker of PCOS and is definitely related to androgen excess and insulin resistance. So if you're not able to tell so much about that, you can go and look at AMH, especially if you're looking at fertility. And so there are certain age-related ranges for anti-Müllerian hormone. So if it's above these ranges, then we would tend to see that the patient would be more likely to have PCOS. So with PCOS, the AMH levels are going to be higher than average for the age. So, a level that would be normal at age 28, if a woman at age 40 has that, you might want to consider PCOS and looking into some of those other elements if she's having trouble conceiving. Another little pearl that can make things a little difficult to see with PCOS is that obesity can mask the altered LH-FSH ratio. So if you have patients who are really insulin resistant and they're obese, they may not have that opposite LH-FSH ratio. So in patients who don't have PCOS, we expect the LH to be, double the FSH or at least significantly higher. But in patients who are obese, you often don't see that as much. So just keep that in mind as well. And I just wanted to cover what insulin resistance does for sperm. It is not good for sperm health either. And there's more and more information now coming out on male fertility and, how actually it has a profound effect on, the offspring's health. And in fact, you can influence it so much. There was a study just in 2017 on 160 men with infertility who had unexplained low sperm count, and they had compared those to a group of men who had proven fertility. And what they found was the infertile group had higher fasting insulin FSH, LH, and cholesterol levels. And that's something I see in my practice too. A lot of the male patients that I'll see, they have that have, kind of borderline issues like lower motility or lower sperm count, but nothing really surprising. But they're not getting pregnant. And you'll see the patient has abdominal fat or has some metabolic markers. When you really get them to work on that, you'll see a big turnaround in the sperm quality. And another study here, can directly actually influence the sperm, and this is not surprising. Overnutrition of rats can cause hyperglycemia, hyperinsulinemia, dyslipidemia that reduces sperm concentration and motility. I mean, this is kind of a no-brainer, and it makes complete sense, of course, because of all the inflammation. And so like, how does this happen? So there's a few different ways. One of the things is that in men who are obese, the elevations in estradiol through the aromatase in adipose tissue will actually exert negative feedback. And then there will be decreased testosterone secretion, and eventually there will be issues with the sperm. So that's one way that this can happen. Reactive oxygen species can also damage sperm directly. So these can come from adipose tissue, from chronic low-grade inflammation. So, we know that reactive oxygen species aren't good for any of our cells, and sperm are, as a very energy demanding cell with a lot of mitochondrial activity, it's not surprising that they're influenced by this too. And interestingly as well, I don't know if anyone is too familiar with the blood-testes barriers. So as we know, there's lots of different areas in our body that have barriers, and where there's protection that's needed. In the testes, the Sertoli cells act as the barrier, the blood-testes barrier, and they actually protect the developing sperm cells. Those sperm cells need to be protected from certain kinds of influences that would affect them as they're developing. The Sertoli cells, actually, there's really interesting research on them. They react in response to metabolic stimuli, and sort of like the follicular cells, they reflect the whole body metabolic dynamics. So they are super sensitive to many different types of toxicants, and that's why environmental toxins have a huge negative effect on sperm. They are rapidly developing cells, so it's not too surprising. Of course, like, the hormones are going to have an impact on the Sertoli cells as well. So estrogen, insulin, leptin, ghrelin, FSH, LH, and testosterone all have a huge variety of effects on Sertoli cell function. So really anything that impacts those hormones in a significant way could disrupt the blood-testes barrier and negatively impact developing cells. So this is some newer research on sperm and why the environment is so important for sperm health. So this is really key. I feel like a lot of patients come in and the males maybe don't even know that they could have an impact, because a lot of the time the fertility clinics sort of say, well, don't worry, we'll just do IVF, so you don't, and ICSI, and you don't really need to worry about that. But yeah, they actually do, because these effects actually, no matter if you inject the sperm into the egg, the sperm is affected by the environment. So it is really important, and we can do a lot in this way. And with epigenetics, we have evidence now too that obesity in either parent prenatally has been linked to the same in offspring. So this is not related to genetic obesity. This can actually be induced in animal studies, so they can make animals obese, and then the offspring can be obese for male animals as well. So the sperm have the epigenetic capacity to pass on insulin resistance and metabolic defects to the offspring. And of course, we know that impaired glucose tolerance in mothers has been linked to insulin resistance in offspring too, for a lot of the reasons we talked about, but also the prenatal environment, which is not surprising. But a lot of this actually happens before the prenatal environment. It happens with the gametes for all of the reasons just mentioned. And then miscarriage. So, like, the first thing to keep in mind is that many miscarriages that are, related to PCOS and insulin resistance, many of those are actually because of the oocyte health. and the follicles. So this is all, primarily before the pregnancy happens. We know this because they have done studies showing that maternal hyperglycemia can affect the progression from a zygote to blastocyst in rodents, even if it's donated to a non-diabetic mother. So taking that oocyte and, from a hyperglycemic animal that doesn't necessarily have genes will definitely affect the growth of that embryo. So that's something that's very important. It happens before. Another analysis of 4,500 IVF and IUI cycles found that obesity correlated with a reduced likelihood of pregnancy unless the oocytes were provided by a lean donor. So that shows us that the oocyte itself is influenced by the environment prior to pregnancy. However, we do know as well that, once you are pregnant, this still does have an impact. So the trophoblast of the placenta at early pregnancy can be significantly altered by insulin resistance. And then during pregnancy itself, insulin resistance is part of pregnancy. So maternal skeletal muscle becomes more insulin resistant. This is part of normal for pregnancy. And then if you look at gestational diabetes, the placenta and the adipose tissue, they actually have a lot of low-grade inflammation. And so in patients who are more insulin resistant and who develop gestational diabetes, there are major changes, that can happen here with the placenta, with implantation, and then we'll see the risks for preeclampsia occurring as well. So it does definitely increase the risks for the pregnancy itself, and so that is important to address it at that time also. So looking at how to assess insulin resistance in the clinic, and this is something that I think is always the first thing is really physical exam, because and just taking a history. Many of the tests you can see insulin resistance, but sometimes patients will come in with kind of the wrong tests, and you can see it. So the number one thing is belly fat, so a deposition of fat more around the stomach area, and I'll show you some more about metrics for this too. Many people with insulin resistance have fatigue or have fatigue around meals or related to hypoglycemia. Skin tags and dark skin patches like acanthosis nigricans, and those will be behind the folds of the skin behind the neck is a common place, under the arms, and even on the knuckles of the hands. You can see that, and it's velvety, dark pigmentation. Lots of cravings for sugar and carbs. And any patient with PCOS, even if they're lean, I would look a little bit more carefully, maybe do some extra testing, see if they are carrying a little more belly fat or if they have hypoglycemia, because they're definitely more prone, and you may not see some of the signs as much if they are more on the lean side. So when it comes to labs, when someone is lean or average weight, you do have to look a little deeper, but some of the simplest ways would be the fasting insulin and fasting glucose. And these are generally very simple to measure for most people. For very lean people, they do tend to have normal fasting insulin. So for them, it can be hard to tell. But for people who have any kind of significant insulin resistance, you'll definitely see that this will show up. In Canada, I like to see 50 or under for our insulin levels. I believe that's about 7 or 8 in the US units, and for a fasting level. So, and then you can enter those numbers into the HOMA IR calculator if you'd like to do that. Many studies use 2.5 as a cutoff, and another study found a cutoff of 1.7. So yeah, so, and I like to look at fasting insulin also just on its own, because I find that's just a very simple test that tells quite a bit. You can also use the Quickie calculator. So I've got a link there for the Quickie if anyone would like to use that. It might be more sensitive. So it's also relating to just using fasting insulin and fasting glucose. So yeah, this is a very simple way to test. It's not expensive and it's easy. The simplest way, though, is just the waist to height ratio. It's pretty accurate. So basically, anyone who's over 0.5, their waist to height probably has some amount of insulin resistance. And the waist to height ratio on 754 women, a study in 2016 found that 71% of the patients who had a high waist to height ratio did have insulin resistance. So it's fairly accurate. And as clinicians, I mean, we can ask our patients too, and a lot of the time they know if they gain weight on their stomach very easily, or if it's on their thighs or other areas. So people usually are pretty aware of this tendency in themselves too, or their family members. Do you have family members that all have weight gain around their stomach? And so many patients are aware of that if that's a tendency of theirs. I just wanted to show some examples of what happens here and why we can't really just rely on glucose and to pick up insulin resistance. So if we're looking at this comparison between two groups of people, one is a group of average BMI and the other is obese patients. And this is their insulin and glucose levels after 3 meals per day. As you can see, the glucose levels are relatively similar for these patients. The obese patients here do not have diabetes. So, it's really difficult to tell if you're looking at something like an A1C that's going to measure an average of glucose control. Theirs might be like a little higher, but it's not necessarily going to be high enough and to show insulin resistance. And I can't tell you the number of patients who come in with their A1C and they say, oh, my A1C, or they say my sugars have been tested, I am not, or my insulin's been tested, I'm not insulin resistant. And I look and see, and it's just been the A1C that's been tested. So really, ask to see what they actually had tested, because if we look at the insulin levels, they're quite profoundly different. So obviously, these patients need a lot more insulin to keep their blood sugar in check, and that causes a lot of other problems in the body. So we need a better way than glucose testing to understand this. So in our clinic, we love to do the 2-hour insulin glucose challenge test. We used to do the 4-hour, but our patients did not love to do that. So we switched to the 2-hour, and it's a pretty interesting test. So we've run, hundreds and hundreds of these, and so what we find is really big differences between patients, and it can detect some of these patients who have, the lean patients who have high insulin responses, and then it can pick up patients who are at the very, at the very early stages of developing beta cell failure, and so it's very interesting. It can develop the degree of insulin release and the sensitivity to sugar and carbs. So it's quite an interesting test, and so it's very similar to the glucose tolerance test. The one that we do is a 75-gram glucose dose, and we test insulin and glucose at fasting, 30 minutes, 1 hour, and 2 hours. I can show you some differences between some actual patients here. So we'd be looking at the glucose levels on the left and then the insulin levels on the right. And so for the same patients, and the reference ranges are at the dotted green line. As you'll see, when it comes to the glucose, all of these patients look relatively okay. Like one of them has come up a little bit over 8. This is our Canadian units. Again, I can't really convert that in my mind, but if you put that into a calculator, you can find out it's just a little bit above the reference range. So that would be our patient number C. And so that was after their glucose drink. But if you'll look, at the insulin levels between these patients, I mean, there's astronomical differences between them. And with these patients, we saw clear differences in their levels of insulin resistance, their levels of symptoms. And then when we are able to improve the insulin levels in some of these patients with very high insulin, they really see major changes with their overall health, but also, with their fertility and ovulation in PCOS. So yeah, this test is great. It's not available everywhere, but if you do have access to it, it gives you a lot of information, particularly if you're not really sure what's going on with somebody. So the next section I'm just going to do here is the naturopathic treatments for insulin resistance and fertility. So starting off with the principles, the first thing is epigenetics. We always want to take care of this if we can. So because of the way that the sperm and eggs develop, starting in advance is so helpful. So 3 months minimum. If you can do 6 months to a year, that's even better. Increase insulin sensitivity and reduce abdominal adiposity. So this is going to be the core of what your goals are here. So it's not really, I don't focus people on weight loss at all. I focus people on, changing their diet in a way that will lower their insulin secretion, balance their blood sugar, and, target lowering insulin levels so they do release that abdominal fat. And then there are some supplements that can be helpful here too. So that's definitely one of the big principles. And then next is protecting oocyte health, and I should also have sperm health in there. We'd be looking at protecting them from the state of insulin resistance. So when there's insulin resistance, there's going to be inflammation. So we're going to look at cell protection. And then making sure nutrient status is good. So making sure that nothing is deficient. There's sufficient amino acids and fatty acids and micronutrients and everything that's needed to provide all of the nutrients that a growing follicle and sperm need. And some of the considerations are that because this is fertility, we definitely want to use safe and low risk interventions whenever we can. So that's a consideration. We can also consider, is there anything that we can extend into the pregnancy? So it's always a good idea not to take things that are completely contraindicated in pregnancy that have to be stopped as soon as you're pregnant, especially if it's having a significant impact. So it's always good to be on a protocol that has a smooth transition into pregnancy, and that in many cases, some of these changes can be extended into pregnancy just to help the whole metabolic process. And then prevent gestational diabetes. So if they start good habits now, they're going to be much less likely to get gestational diabetes, which causes so many problems. So the first thing is, when it comes to eating for insulin resistance, there are a few principles that I follow. The first is to stabilize the blood sugar. Without stable blood sugar, patients will become hungry, they will crave carbs and sugar, and they will not be able to continue, basically. Starvation does not work very well. Just strict caloric restriction generally does not work very well long-term for insulin-resistant patients, particularly if they have androgen excess. It's very hard to be in starvation mode, and it can cause a lot of emotional distress. So I always prioritize keeping the blood sugar stable, even above anything else, actually, when it comes to the diet. The next thing is that I optimize the insulin response to food. So I always suggest foods in certain categories that are not going to trigger massive releases of insulin. So balancing out the plate so that you don't have an overabundance of very insulin stimulating macronutrients like carbohydrate. So optimizing that response while keeping the blood sugar stable, and then choosing nutrient dense foods. So making sure that the foods are, as nutritious as possible per calorie, and they have as many nutrients as amino acids, fatty acids, as much dense nutrition as we can get. So dietary change is absolutely essential, and there are so many patients with PCOS that come and see me who are told that all they need to do is take metformin, and then that's enough to deal with the insulin resistance if they'd like to get pregnant. And unfortunately, metformin does not do very much. When it comes, it's a minimal impact. It has a small impact, but what you eat has a massive, massive impact. And there are many different methods that can work, and I don't want to say there's any one that's best. I'm going to show you one that I use with my patients that I find works really well, but there are a lot of different ways that this could be done. You could also check out Mastering Your Diabetes by Mona Morstein. She has a lot of dietary information in there as well that would work really well overall. So this is what I like to suggest, but again, there's so many options. When I think about balancing blood sugar, it's always crucial to think about the two macronutrients that balance blood sugar that have calories are protein and fats. And so when you combine those two together, you will achieve stable blood sugar for a long period of time. When you add fiber into that mix, you're going to achieve even better blood sugar stability. So I always start off with counseling the patients to start, to have lean protein, 25 grams a meal at least, 2 to 3 cups of non-starchy vegetables, and a good serving of healthy fats, because healthy fats don't stimulate insulin release. Of course, we want to choose, the best fats possible, but really encourage the patients to eat this because lipids are very important for fertility, and we don't want to be deficient in key nutrients either. And then quantity controlled carbohydrates. And the amount of carbohydrates per meal, I vary depending on the patient and depending on their sensitivity to carbohydrates. And of course, we want to go with the low glycemic index or resistant starch types of carbs, which I'll talk about later. Those are always best. So it's the lean protein, non-starchy vegetables, healthy fats, and then carbs that are low glycemic index, minimize sugar and processed foods. So, and of course, avoiding environmental toxicants is key as well. So any way that we can avoid animal products that are, produced with hormones and that are not organic, that's going to be very, very important as well. So these dietary changes will make the biggest difference. The supplements can be extremely powerful too, though, when it comes to fertility. But I always really emphasize the diet for a lot of patients. I find when it comes to fertility and IVF, it's such a medical process for the patients if they're not doing natural, that they almost are overwhelmed and they feel a lot out of control, And so when you give them this ability to make such a huge difference, it's really amazing how much better it makes them feel, just be able to improve their own outcomes that way. There are some great supplements as well that we can use. So berberine is definitely one that we use quite frequently. It has a variety of different effects on insulin resistance. It provides metabolic benefits on the microbiome. So similar to how metformin works through the toll-like receptors and TNF-alpha pathways. It actually, new information suggests it can increase the GLUT4 expression in muscle tissue and the insulin receptor expression. And it's been known for some time that berberine doesn't really raise in plasma levels very high, but there are many metabolites of berberine. And what they've found is that these metabolites actually have pretty powerful effects on insulin resistance. So that might be why it works quite well, despite the fact that it's not raising the plasma levels as much. Berberine can also activate brown adipose tissue. And it's been found in a meta-analysis that to be similar to metformin in alleviating insulin resistance, which I find to be quite true clinically as well. Resistant starch. So resistant starch is very, very safe for the entire pregnancy. So it's a great thing to start people on. And as a carbohydrate, it's definitely superior when you're looking at insulin resistance. So a systematic review from 2019 found that 30 to 40 grams a day decreased the fasting blood glucose, but just 10 grams a day was enough to reduce fasting insulin, which is very doable for people. So there are many types of resistant starch. You can, I often suggest the Bob's Red Mill potato starch or green banana flour or larch arabinogalactin, and asking patients to take, 2 or 3 tablespoons of that, stir that in water and have that with their dinner. Can be a great way to add resistant starch. And this is slowly metabolized by the colonic bacteria. It can improve metabolic health for 24 hours, just after a single serving, but over time, it really can make a big difference for patients with their metabolic health. And it's a food, so it's very safe to continue throughout pregnancy. Another one that's really quite safe is konjac glucomannan. So this is a fiber from konjac root. This has been known for some time to slow the absorption and the rise of glucose postprandially by forming a gel around the meal that you've eaten. So it makes the glucose go up more slowly. It also really makes you feel full. I don't know if anyone's tried this, but every time I have it, I am full for a long time and I just can't eat. So it definitely increases fullness. And some recent information actually shows that it might have direct effects on glucose metabolism in the liver by increasing GLUT2 expression and through the AMPK and mTOR pathways. So it's kind of interesting and also very safe because it is a fiber. And of course, I wanted to cover inositols because these are definitely one of the more researched supplements that we have in our toolbox when it comes to fertility and insulin resistance. So the inositols are really interesting because not only are they the second messengers for insulin inside the cells, the follicles have large amounts of inositol inside, and it's very important for egg development. So even for patients that don't have insulin resistance, inositol is beneficial for oocytes and follicles. So I just want to run down the different types of inositol because there's sometimes a little confusing. So myo-inositol is the main type of inositol that you'll see most everywhere. It's very affordable. It's 2 grams twice a day in most studies. And it's an insulin sensitizer. It's an enhancer of oocyte, sperm quality, which many people don't know, and embryo quality. So it's very helpful for the quality of the gametes themselves. It releases, regulates glucose transport. It improves basically all the parameters of PCOS. D-chiroinositol is primarily more beneficial for insulin resistance. It's definitely an insulin sensitizer. It regulates glycogen synthesis. But one thing to keep in mind is that high-dose D-chiroinositol can be potentially negative for embryo quality. So 100 milligrams per day is safe for trying to conceive, but if you're going above that, you know, to 1.2, 100 to 1.2, it is not okay for trying to conceive. That could be toxic or negative for the embryo quality, according to research. There is a combination using a very small dose, however, of the D-chiroinositol along with the myo-inositol and the 40-to-1 ratio, which is the ratio that's in the bloodstream typically. And so much, much more myo-inositol and much, much less D-chiroinositol. This seems to be possibly superior to you know, the myo or the D-chiro. And no negative impact for the embryo quality, but I don't think it's vastly superior to the myo-inositol, but it's according to some studies, it looks like it may be superior in some ways. The other consideration when it comes to supplements are antioxidants. So as we spoke about, you know, in insulin resistance, you know, it's great to work on it with diet. And of course, you know, exercise, of course, is very important as well. But when it comes to the reactive oxygen species, it's very important to protect the oocytes and the sperm because they are so susceptible to that. And the mitochondria are very susceptible. So you can choose from a variety of different fertility safe antioxidants. The common choices would be coenzyme Q10 or PQQ. These are mitochondrial antioxidants, so they will help protect the mitochondria. The polyphenols generally are safe for fertility. So, for example, green tea, pine bark, these types of substances are all generally safe. Grapeseed, you know, they do have a lot of evidence for inflammation as antioxidants. N-acetylcysteine, again, is a great antioxidant it helps with insulin resistance, and it's very protective against oxidative stress. Resveratrol, and the carnitines. So the carnitines can help with mitochondrial stress, but also, especially for male factor, can be really helpful for motility because of their impact on helping with energy production through the mitochondria. So the carnitines are definitely a top pick for sperm. When it comes to anti-androgens, there are many that we can choose from. And if a patient with PCOS does have a lot of androgens, I often will include some anti-androgens because that does contribute quite a bit to the insulin resistance. So we have a variety that we can choose from. So white peony, licorice. So the peony and licorice formula is commonly used in traditional Chinese medicine for PCOS. These also have anti-inflammatory effects as well as being anti-androgens. EGCG, so green tea actually has anti-androgenic effects. Saw palmetto, so particularly for DHT, so 5-alpha reductase inhibitor. And spearmint, so spearmint tea or spearmint leaf extract can be used 300 to 600 milligrams per day, or you can ask patients to take 3 tea bags and put that into a cup and drink that and sip on that throughout the day. The studies are on 3 cups a day, and most people will not do that. So that's one way I found that many people will find, where they can do the spearmint tea at more of a clinical dose. Pygeum is another option as well. So depending on your patient's needs, you could choose some of the anti-androgens. Omega-3 fatty acids have a lot of benefit for fertility, for insulin resistance. So these fatty acids have been studied in so many different ways when it comes to fertility. So a study of 100 women undergoing ART found that the patients who had the higher omega-3 concentrations had a higher probability of pregnancy and birth. And that was primarily driven by EPA content. Another study found that EPA improved the gene expression in the granulosa cells, which are often deficient in PCOS. So that's very interesting when it comes to helping women with PCOS create estrogen. In angiogenesis of the placenta, the EPA will actually reduce the inflammation and help with the placenta's function and growth. And then when it comes to males, there is a recent systematic review in andrology that showed that supplementation with omega-3 had a positive effect on semen quality markers, which was more prominent with a higher dose and longer duration of supplementation. So omega-3 fatty acids are always kind of a cornerstone that can be continued into pregnancy. So our conclusion here is that, when we're looking at having a baby, improving your metabolic health is so important because it not only is going to impact both female and male fertility, but it's also going to provide major long-term health benefits for the patients. And they're going to learn habits, and they're often going to keep doing those habits while they're pregnant and through the rest of their life. And they're quite motivated at this time to make different changes. For patients that are undergoing assisted reproduction cycles, it's a very disempowering process, and it can be very stressful, very disheartening, and it's empowering to them to know that they can make a difference with something that they can actually control. And then finally, the good maternal and paternal metabolic health in these times, it's going to create beneficial epigenetic marks that persist for generations ahead. So we're not just helping our patients, we're helping many, many generations in the future as well. So thank you so much for watching my presentation, everyone.
Great, thank you so much, Dr. McCullough. We're a couple minutes after the hour, but if you're willing to stay on for a few minutes for some Q&A, I can filter that your direction. Okay, great.
Yeah, sure.
So for those of you who have questions, you can either type them in the GoToWebinar control panel there under the question section, or if your question is a little bit more involved, or it would just be easier to ask verbally, you can feel free to, there's a little hand icon, you can raise your hand, and I can unmute your individual line. So let me just go over here. Oh, you're getting lots of accolades. Great job, Fiona. Thanks for the good presentation.
Thanks, guys. I appreciate that.
Here's a question. How does one assess for impaired insulin clearance clinically?
Yeah, so, probably the best way to do that would be the insulin glucose challenge test. So what you would tend to see is with those patients, they tend to be lean. Many people who are obese, they're going to have that as well. But for the lean ones, what you'll see is that their insulin will rise higher typically than you would see in other patients, but then it will not go back down. So by the time you get to 2 hours, the insulin levels should have dropped significantly, not all the way to fasting, but you should see them come down quite a bit. For those patients, they stay high, and sometimes they even go back up again. So that's really the best way that you can tell.
All right. And the next question, which is a follow-up to that, is, and do you manage those patients the same from a treatment perspective? I'm assuming those patients meaning like lean and obese.
I do. It's different in certain ways. So for them, they have a lot more control over what's happening because they don't have the baseline insulin resistance so much. So I do definitely counsel them to eat in a way that does not trigger their insulin. And they're actually quite motivated when they see their levels. So for example, like, and these are again the Canadian units, we tend to not see metabolically healthy people ever go above 400. And they don't have to be obese, or lean, like just average weight. But some of these people can be very lean, for example, who have this clearance issue, and their levels will go to 1800, and you'd just be shocked because their fasting is normal, and then their levels, by the time they get to the end of the test, they're at like 1000, like they're still incredibly high. When they see that, they are quite motivated not to overdo it on carbs and sugar, because they see the visual of the level that's happening. So I do counsel them to eat in that same way. And then I also, tell them that they're much more sensitive to sugar and to eating carbs that aren't balanced out with proteins and fats. So I do tend to manage them the same way. If they are going to eat carbs, I often give them something like glucomannan so that it doesn't trigger up their insulin so much. So I often give them that as a tool to use as needed as well. One other thing I thought about too for the lean patients, if you can get them to gain some muscle mass, especially like in their lower body where there's more GLUT4 receptors, they will be able to dispose of that much better, and they'll become more insulin sensitive, so that, even though they are a slow metabolizer, they won't have the spike as much. So that's another thing you can do for those patients.
Great. Any other questions? I'm not seeing any typed out ones. Let me just double check and see if anybody has their hand up right now. All right. I'm not seeing any other questions. You just explained things so thoroughly, which is wonderful. And if questions do come up for people as they're kind of thinking about this, or if you're listening to the recording of this on the EndoANP member site, which is where all of our archives are stored, as a reminder, our EndoANP members chat group on Facebook is a great place to continue the conversation about this and ask questions. And Dr. McCullough is on there frequently, and she can directly answer them. Or again, other members of our community might have great feedback on this as well. So I really encourage people to kind of continue the conversation of this moving forward. And yes, I think that is all I have for right now. Stay tuned for our EndoANP newsletter next week, which will have announcements about our upcoming webinars and some stuff that's going on. And with that, everybody have a wonderful evening.
Have a great evening. Thanks, everyone.
Good night, everyone.